All right, hi. This is Stuart.
And this is Selena.
Welcome. We're going to talk about databases in the cloud.
Why? Because all the other shapes on PowerPoint were already used for things like computers and network connections, so the cloud was the only object left, so therefore new technology got called the cloud. And databases in the cloud are, of course, this wonderful magic solution that, without explaining any of the technology behind it or coming up with any real solutions, will instantly make everything scale and be perfect.
Solves all of your problems.
All of your problems, so don't worry. All you have to do is, when someone asks how you're going to solve with scaling, you just say, we're going to put the database in the cloud, and then you can go home because it's already done.
And now our talk is done.
Yeah, thanks. That's all you have to do. Yeah. So since we're not in the world of Harry Potter and we can't just tap a wand and make that happen, we can now discuss the depressing reality of what is referred to as database in the cloud. So once you've gone off like the absolute hyper speed-induced like marketing drugs, you can then come back to reality and here's the problem. So I thought we'd start first about like in the beginning. So if you think about typically about what happens when you go and use like a database as a service as some like shared hosting thing, right? So everyone pays, $2 a month and gets some account and some machine with, a mysql or a postgres instance on there, well, part of it or whatever, and then what happens there. So there's a bunch of problems even in that simple scenario. If you even think of, I'm going to just whack it in the cloud because I really don't want to be a DBA admin, and really cloud is just a new word for, shared hosting in a lot of situations, especially when it's a small app. So the MySQL way has typically been that someone either writes their own little magic foo or gets somebody else's magic foo to basically say every user in the cloud now gets like one database. And if you wanted 2 apps, then you better hope their table names don't conflict, because otherwise you're screwed. And of course, you get one user account, and it has privileges to all that database. So if you actually want to do things interesting, like maybe have a read-only user and a rewrite user for different tables, and like be able to have some privilege separation, you don't. Which is why every single web app in the entire world written towards MySQL has one user that it connects to that has rights to do absolutely everything, including drop table, and we're all sad and little Bobby Tables doesn't get his school results. So we have problems there. We also have other issues of like, of course, in these setups generally you don't get replication because that's hard, and it turns out MySQL's replication system, of course, then you could be the one user on the machine that decides to run a query across a gigabyte of data. That's very, very excessive, and then locks everyone else's replication for the next 4 hours. So that has a few problems there in a shared environment. So basically it works quite well if you're running very small apps. One of them as your user on the one machine. You don't really care too much about performance, of course, because in the time between your app last being accessed and now being accessed, probably all of your pages have dropped out of the buffer pool and out of cache, so it has to come up from disk. But it kind of works for everyone's personal WordPress blog, so it's done that way. But of course, as soon as someone gets beyond a limit, you've got problems. You have to go to something else. And there's a bunch of architectural problems sort of in the server that doesn't make it any easier. And there's also a bunch of problems in the fact that it just works for so many people on a small scale that it's kind of prevalent in this odd kind of way and causes some really bad design decisions, because there isn't a good way to have different users and different databases in there, and there's always some script that prepends your username to the schema name and other horrible things going on that it's not necessarily very good. No one ever runs good disk I/O behind it anyway, but it works for a lot of situations, and this can be sort of in the cloud for small things. And for a lot of apps, really, you don't get that heavy use, it's fine, and everyone tends to do this inside an organization anyway. Why deploy 7 machines you have to do admin on and DBA on when you could just have one and take it back up? How is the Postgres world?
Well, if we're talking about in the beginning, if you called up a shared hosting provider and said, hey, I'd like to use Postgres, they'd be like, what? Really? No. So that continues to be a problem. We now do have several shared hosting providers and even like Postgres as a service being offered by a few companies, but it's relatively new. So we are just young in terms of being able to provide that type of service operationally, and there hasn't been a great deal of work in our community on making that easy. So things like just doing an initdb used to be incredibly slow. We've made some fixes for that now, so it's a bit faster. But for example, you can't do an initdb copy that particular database instance without bringing it up and then expect replication to work. Kind of a problem. It was just, for so long, we were the vertical scaling database, right? Like, why would you want to have lots of little Postgres instances? Full stop. You know, like, it just really wasn't a priority for our project. So that is changing now because of companies like Heroku that do now have, you know, tens of thousands of instances running all the time. And they're becoming very interested in helping us move forward with some of our user interface problems that we have like that, and just addressing these system administration issues. And really, a lot of the same issues that Stuart just brought up about user management. You know, you set up a database and then all of a sudden, you know, you have these unique users across every single database that's in that particular Postgres instance. That's kind of an issue. We have incredible role management in Postgres, but it's like Byzantine and awful to administrate, and so you still end up with these applications that people write where they're just using a single user instead of actually using the role infrastructure that's there. So we have a lot of work to do on the user interface side to make that easier. And then until very recently, most of our replication, real replication systems that people were using in production were third party. So you'd use something like Sloaney. There were some other things like Picardo, and there's Londiste, but they're third party. And so there were lots of companies that just did not trust them because they were not distributed as part of core Postgres. And so then we got the reputation for just not really having proper replication. Now we have that, and it's very exciting, but you know, we're still making incremental progress every year, and it's relatively new, and it's a lot of code, and it's working really well, right? But you know, it's still kind of, people are cautious. You know, we're not really sure that it's ready for the type of loads in the cloud that MySQL has been supporting for a long time.
Well, half of it's by accident, and the other problem, of course, with the whole author infrastructure is like it's all Byzantine because every part of SQL to do with users and permissions is designed for someone sitting in front of a VT100 terminal writing in SQL by hand, and not at all maps to a web app. So it like, is complete disconnect, which is, you know, absolutely ideal for the modern world. And we've wonderfully, as database developers, stuck our head in the sand and not done anything about that. So, you know, you're welcome for solving that problem. And of course, this is a problem that's been in the beginning. So we've had a fair bit of warning now. You know, shared hosting's been around for a while, and, you know, still not fixed. Thanks.
All right, next point.
Yeah, so I want to say the next point was like, if you think of like sort of Cloud V1, it's like, oh, we can dynamically do things. It's like, here's a pre-built virtual machine image that has a database server installed on it. And precisely 2 people used those, and they were both the ones that created the images in the first place that fit their hardware and their specific setup. So that was like, you know, completely a waste of time, and no one ever did it. It turned out apt-get install, MySQL apt-get install Postgres was really quite easy on your own machine, so it wasn't really a thing.
Yeah, agreed.
Yeah, and then it comes on to the other issue, which comes on to, you know, the sort of second sort of thing, which is a whole bunch of database as a service. You start to people having actually use a database inside a virtual machine, which has its own set of problems, because it turns out, how do virtualization, performance, and databases go together?
Correct.
Yeah, it's great if you're not used to performance in the first place.
As well as databases and migrating file systems.
Yeah, it's almost as well as pouring honey on your hard disk. I've never done it. It probably works really well, but I wouldn't recommend it. Yeah, I mean, virtualization has a couple of issues there, right? I mean, one, you've now somehow, amazingly enough, running more than one VM on the machine does not magically give your I/O subsystem any more IOPS. Yeah.
Sorry to be controversial.
Yeah. Yeah, magic doesn't happen. And you end up this wonderful situation. So instead of being able to do, you know, like 300 syncs per second or something on this one database instance, oh, let's just put 10 of them there, right? Everyone gets 30, which is like less. And it turns out that the big overhead tends to be actually when you want to write something to disk, if you care about disk durability. But what turns out is like a bunch of virtualization people found out is really fun. If you don't pass the flush commands down to the
it's so much
virtualization
faster.
system, it runs so much faster.
So much better.
Until your database as a service customers come back and go, why does none of my stuff work anymore? It's all corrupt. Why? How could this possibly happen?
Yeah, so once again, we're back into the situation where you cannot trust the vendor at all.
Yeah, and I mean, what happens if it doesn't work and you end up that way? What can you do? You're now buying database as a service, so you can't do anything about it. You can just sort of ask them nicely to please not corrupt your data anymore, or hope they use, a virtualization system that actually does respect that, and hope that, all the file system code in the middle there is the versions that actually work. And you may or may not have access to the underlying, OS image there, so it's even more fun so that you can't fix it yourself.
Question?
Stuart, I'm curious. I've been fighting a bit of a losing battle against virtualization. My argument very simple. Hey, if you own the hardware, why are you wasting all the context switches and blowing out your caches, swapping it out all the time? If the counter argument is manageability, right? Have you been able to see it pair off or come apart with only one VM on physical hardware? Does the problem go away just a little, or is it a non-starter if you really need to be on physical hardware? I'd love for you to say physical, because then I feel better about myself. But if one VM on a physical box is okay, well, then be working.
Yeah, I'm going to say physical just because that gives you one less problem. And once you start running with too many layers, database is fragile enough as it is. And you've got 99 problems, you may as well have 99, not 100, with the extra layer of virtualization stuff there. And I think Avi's done more benchmarks on various databases that he totally cannot say numbers publicly with. But
I'm not going to say our numbers.
Oh, your numbers. Yeah, you'll say your numbers.
Yeah, you can talk about us.
I can talk about Oracle and MySQL and virtual. I haven't done numbers for virtual.
Yeah. Yeah, it will be less bad, because the main point is that when you're restricted on IOPS, you're still going to have your base IOPS, so it'll be less bad.
The only factor, utilization is the other one.
It's the idea of you bought this magnificently expensive piece of hardware, but your database is only busy for 20 minutes a day when it's doing its batch process at 5 o'clock. Why can't I use all that hardware during the day for the other things that need that kind of speed? And it's instead of having a database server that's 10% utilized most of the time and peaks at 90%, I can run all my servers at 60, 70% utilization and get the biggest bang.
Yeah, I mean, it depends on workload. Like that can work very well when you have batch operations. Unfortunately, most web sites don't tend to have a giant batch operation. It tends to be more of a static load and then a peak and a sustained load and down, depending on if they've acknowledged the world outside the United States yet or not. And so you end up with this kind of interesting way. We tend to see people ramp up and then use at least one and more. So you end up with this kind of interesting scenario there of even just the base layers.
And there are some companies that are doing interesting work with that. There's this company called Gilt that has created a great deal of infrastructure around trying to manage that load. But I mean, it involves a level of monitoring and knowledge of your systems that honestly, like most IT organizations don't have that sophisticated level of monitoring. And then they also don't have the staff that can write the tools that you need to do that, because the tools out there in the cloud for doing this, they don't really work.
Yeah,
in my experience.
Yeah, I mean, you have a whole bunch of issues at various points where you're simply like, well, if you're buying database as a service, then you get this database server. Does that mean you can even set half the options? Yeah. And then you have the issue of especially if you have pluggable replication systems. Does that mean you get to choose that? As MySQL, does that mean you get to choose how your storage engine is configured, like how big the log files are, and how much memory is used for buffer pool, which can be distinctly different, and can you limit the data dictionary cache, and you have all memory management issues when you hit large enough scale.
Right, so the bigger issue for me about people trying to put large systems in the cloud is that it just doesn't work with the large systems, right? Like for the smaller systems, for people who are just starting out, for prototyping things, for a website that is never going to, be that large. Like I think that it totally can work, right? But when you get to the point where you really do need that performance and you need to migrate off, I mean that's the question. His first question is, can you? Is it possible for you to even get your data out in a reasonable way and move to something that can provide the performance that you need? And so, if you have any inkling that you are going to go there, you have to, from the beginning, plan and know that it's possible for you to get out of the system you bought into.
Because remember, at a point, a SQL dump is no longer a viable way to restore. It's like, I can just do a SQL dump and connect to the socket. It's like, great, this is going to take me 2 days to restore from somewhere.
So how do you move databases?
How do you move databases?
Very carefully.
How do you
I'll be working for Oracle, can totally recommend Oracle Golden Gate.
Perfect.
Yeah, I mean, it depends on the system, right? So you can do like online binary backups from MySQL using like either the Oracle commercial product or the Pacona open source one. Full disclaimer, I work for Pacona. Or you do it in a variety of other ways. Worst case being SQL dump and sharding, or just take some downtime and the like. But we should probably, since we're running out of time, also talk about the last point here, which is like multi-tenancy built into the database to alleviate sort of the management pain of having multiple sort of end users sharing one physical database server and not running into half of these problems, or at least giving them problems to someone else. I've done a whole bunch of work, which I'm talking about tomorrow, to make Drizzle do sort of true multi-tenancy in the database. So instead, we inherited from MySQL the whole thing of like, you have schemas or databases in MySQL talk and tables inside them and sort of one global set of auth. So in Drizzle now, I've got another layer on top of that, which is catalog, which is basically like then each individual sort of cloud customer there can get their own space through their own authentication tables, their own database names, their own schemas, their own usernames, and then you can do sort of resource limits per catalog. So you can say each user gets 10 gigabytes of buffer pool storage, and they all go into that particular point, and they could each get their own replication stream, and so you could replicate them differently depending on the users if they turn that on or off, which is kind of neat. And then Selena's magic word is going to be, oh, we've had that for years. So.
Aw, I didn't get to say it.
So say it, like, why? Yeah, come on.
We've had it for years.
Yeah.
The area that Postgres is really focusing on right now is binary replication. And I'm going to actually, just right after this, show you how that works and where we're kind of going with the future of our replication. And there's a lot of things, actually, that Drizzle does that we are aiming for. Lots of cool ideas around being able to replicate individual databases, potentially individual tables and rows, because the binary stream is filterable, which would be really exciting. And then there's a lot of work because of companies that are creating these Postgres as a service services. They're really interested in making the UI better. PSQL is a super powerful tool, but it's like not very friendly. And we don't have a lot of other tools out there for just managing Postgres itself that are very good. So.
Yeah, we can basically summarize the last point I wanted to say, which is like auto magic, replication, sharding, and magic that's instantly going to make all your database and application scales. Yeah, all of those people claiming that are lying.
Yeah.
Right? It's pretty obvious you can't magically make source different. They can't violate the CAP theorem or Moore's law or anything that way. There is something in there that you're going to hit. So you always end up having to think as an application developer about, okay, so how can I partition data, or how do I actually build a high availability cluster this way and for these kind of queries, and do I have separate databases for archive stuff? You end up going to have to think for that. It turns out no one's come up with the one magic algorithm to solve all your problems.
Yeah,
and anyone
really
who's currently claiming it doesn't beat your database technology is at least 10 years old to make it stable test.
And also, it really is the application developer's fault for not writing an
scalable code to begin with.
Yeah, right.
Bad queries. I mean, really, our databases are perfect.
They're really great. All right.
So yeah, that's not a very happy situation of the world of databases in the cloud, and basically everything's not ideal, but the marketing's there. So, we're all saved that way, but at least if small, it's not too much problems, it'll kind of work.
It's raining, effectively.
Yeah, it's raining. It's not quite, a beautiful cloud in the sky. It is raining a bit and possible hail. Because it's magic and solves everything.
The interesting thing about cloud.oracle.com is it's not virtual databases. It's multi-tenancy on hardware.
Yeah.
So the back end of cloud.oracle.com is Oracle DBS systems, or the Exadata and Xmargin hardware. So there aren't actually virtual databases. Get your database on hardware using Oracle multi-tenancy resource management to do quality of service and IOP dedication, memory dedication, and that kind of stuff.
Right, and there are some Postgres vendors that are offering very similar things.
And we'll have that for Drizzle when I get the last bits of code in.
Yeah, and you can find vendors. They are somewhat boutique, but you can find them, and they will provide what seems like a pretty excellent level of service. But again, it's not it's not the same thing. Like a lot of these technology, it's not the same thing that we have been talking about here. A lot of these technologies, they're based on top of AWS. And so you are subject to whatever AWS outage du jour
Or
there
if
is.
they like or don't like your content.
Also that.
We should probably stop and let you talk and offer anyone a cookie.
Thank
Totally
you.
have cookies. Thank you all.
Yeah, thank you.